So let us now consider for variance, and again we will be doing it from Poisson distribution only. So test for variance in case of Poisson. So here also we are going to import the necessary libraries and perform these steps. So maybe I could use something from here. So I would like also to show you what is the difference when you are doing for mean as well as for variance. So here these things would remain the same. Sample size, till this point we are generating the sample, so those things will be same. So we are first of all importing the library, and true lambda is 3.5, sample size is 100, and n is 1000. So we are generating Poisson random sample from this. Now because we are dealing with variance, so we need to find out the observed variance, not the observed mean. Observed variance here would be calculated using NumPy's wire function, data and DDOF as 1, so which basically means that you are going to work with the sample variance, and your hypothesized variance, let that be 4. So now the first thing is that you need to consider the difference, that is observed ST, maybe we can find out the difference between the observed var minus your hypothesized var variance. Okay, so T is x bar, or sorry, S1 square, or the sample variance, minus your hypothesized variance, that is sigma naught square. So one thing is done. Next what we have to do is that we have to generate this bootstrap samples. For that we first of all need to define the function. So define, so bootstrap sample, so here we will mention data and observed variance. So the sample will be taken from here, Poisson true lambda, and size would be the length of the data that we have taken, or maybe we have specified the sample size also, so that also can be specified. Then we will calculate for this sample, we will calculate the sample variance, that can be easily calculated. Now this is going to return the difference between sample variance and the hypothesized variance. Why? Because here T is what we have obtained, so this is T basically, right? And here we are trying to find out TIs. So this is for single sample. Now if we want to generate for n bootstrap samples, so this one would be bootstrap st. So here we are going to call this function, for in range n. Okay, now you are ready to find out the p-value. So p-value, for that we need np.mean, and we have to find out the absolute value for this bootstrap statistic, and we have to check if that is greater than or equal to the absolute value of your observed statistic, that is T. So we are comparing T and TIs. Okay, so these are also your TIs. Now you can simply check whether you have to reject the null hypothesis or not. So we can simply copy it. If the p-value is less than or equal to alpha, so what we see, we are failing to reject the null hypothesis. So this also tells you about what is going to be the p-value. So let me just check it. It is 0.973. Obviously it is very much high. So if you can all make some changes in these parameters. So it is reduced to 0.83. So maybe we can change this to 10.492 we have obtained. So you see that we can make this change. This 0.0, so how about 40? That is also quite high. 20 is going to 0.088. Still it is rejecting, but yeah, if you increase this hypothesized variance, suppose say 25, it might be, yeah, so you can see that it is now rejecting. So what is the value? It is 0.017. So you can see that how your conclusion just varies depending upon what are the values you have substituted. Okay, so you do not have to update it at all the places, just one place if you are specifying, because its value is stored in this variable. So if you are reusing it, it will again be automatically updated. So this is how you can test for the variance in case of Poisson. And if you have the two populations and there you have to check for the difference of the two variances, test for variances, difference of two, let us consider this time. So earlier we considered for the ratio. Since Bootstrap is capable of doing all these, I mean, it can either be considering the differences, so we can just use it and see. So some basic things we can copy from here. So we are going to import these two. We need two true lambda 1 and true lambda 2, so let that be 4. So sample size is 100. So data 1 maybe can be from the first sample, and likewise we can have data 2 which corresponds to f theta 2, or you can say Poisson with parameter 4. So these are your samples. Now you have to calculate the observed variance. So observed variance 1 would be np.var, okay, for the first data 1. Likewise you will also have for the second one, that will be np.var data 2 ddf as 1. So you have obtained S1 square and S2 square. So you can consider their variance, difference of the two. So we have been using observed statistic, this variable. So let me just write the difference of these observed var1 minus observed var2. So this is your t that you have calculated. Now again we will write the bootstrap function here. So we are going to write that. So define bootstrap function. So here we can write data, and this can be your lambda. Again the sample will be taken, Poisson size is equal to so sample variance will be computed now. So sample variance would be np.var. Again for each sample that we will take, we will compute its sample variance, and it is going to return the sample variance because it will be the difference of the two. So hypothesized mean is not required over here because we need si1 square minus si2 square. So now you can generate the bootstrap st1. So this one would be, we will call this function so it will be for data 1 and here it would be true lambda 1, okay, for in range n, because it will be iterated these many number of times. Likewise, this function could be for the second one. Here it will be taken from second data set, and here it would be twice, so that. So your p-value here would be np dot mean. So again we are going to consider the numpy's array function, and p dot absolute value so bootstrap statistic 1 minus np dot array absolute of this is greater than equal to observed st. So these are your TIs, difference of the, not the difference, but you are comparing the TIs and your T's, right? So let me just check if this, what is the value for P. Maybe I will just make it lambda 1 data, oh sorry, so it comes out as 0.452. so obviously this is going to be much high than whatever alpha you take. So if it is a 0.05, then we are going to anyhow, we fail to reject this null hypothesis over here. So we have seen the 4 different cases for Poisson distribution, that you have single sample, then you can find out, you can test the population mean, you can test population variance. Likewise, if you have 2 sample problem, then you can look for the difference of the 2 means or the difference of the 2 variances. So we can also consider any other distribution, and the same process will be done. So for exponential, we are going to test for the mean. So we will import numpy as np, and from scipy.stats import exponential distribution. Again here we need the sample size. So sample size could be 100, and the number of bootstrap samples that we want can be 1000. Suppose here we consider case 1, which is for test for a single mean coming from exponential distribution. So here let me define the true lambda can be 1.5 suppose. Then we are going to first of all generate exponential random variates from this PDF. A scale would be here 1 over true lambda. So we are basically considering this form of the PDF. So as you know, there are 2 forms of the exponential PDFs, and size would be same as the sample size and random state would be. So once you have the sample, you will calculate the observed mean, okay, because that is x bar np dot mean, and here you would write your data. And likewise you will have the hypothesized mean, then mu naught, so that suppose that is 1.8. Now you can find the observed statistic, that is the difference between the observed mean and the hypothesized mean. Okay, so this basically gives you t. Now we are ready to define the bootstrap function. So define bootstrap sample. So here we are specifying data, and from the observed mean. So the sample would be again taken from exponential this time. So this would be scale over 1 over observed mean. Okay, and the size would be basically the length of the data. What would be the sample mean here? It will be calculated using NumPy's mean function, and it is going to return sample mean minus your hypothesized mean. Okay, because we want x bar minus mu naught. So now if you have to find out the bootstrap st, so what it will be, we are going to call this function. Now we are ready to find out the p-value. So p-value, again it would be np.mean, the absolute value of this one and the absolute value of the other one, that is your observed one. So let us see what is the p-value here, because it will be greater than equal to, I have to check, I have to make the comparison. It is not like a subtraction thing.